last example here, very similar to example 2. This calculation specifically will be really useful in the lab in the next section. So how much power is developed by a 48 kg girl? And just for reference, since most of us don't measure our weight in kilograms, we measure in pounds, that would be the equivalent of 106 pounds, running up a 5-meter high flight of stairs in 3.0 seconds. So we know we're going to need to get to power at some point, and power is work divided by time. But as with example 2, we don't have the work, so we'll have to work backwards. We know that work equals force times displacement. But again, we don't know the force. We do know, though, however, that this girl is running up the stairs, meaning we're going against gravity. So we can go back to calculate the force and use that F equals mg. Working back to finding the variables, mass, we have to use kilograms for a scientific calculation. That 106 pounds, again, is just for reference. The displacement is 5.0 meters. The time, 3.0 seconds. Go and calculate the force now. Force equals mass of 48 kgs times g of 9.8 meters per second squared. Gives us a force of 470.4 newtons. Work equals force times displacement, so 470.4 newtons times 5.0 meters would give us a work of 2,352 joules. And going and calculating the power, power equals 2,352 joules of work divided by 3.0 seconds. Rounding it to 2 sig figs would be 780 watts of power. Now, just in case anybody's interested, watts are used widely with any kind of electrical appliance. So if you see a 1,000 watt microwave, it uses 1,000 watts of power to heat up your food. But in terms of vehicles, nobody often talks about how many watts of power a vehicle outputs. They talk about how many horsepower. And just for anybody's interested, 1 horsepower would be 746 watts. So this girl is actually putting out more than 1 horsepower, just a little bit more than 1 horsepower going up these stairs.